Don't tell Ethan anything about this. Shh. Okay. Sorry, Ethan. Forgot to record for you, buddy. Okay, so inverses. So an inverse, you switch the x and the y around, and you solve, and that's how you find an inverse. So when you have a function like sine of pi over 4 equals square root 2 over 2, that's a normal sine. So the inverse sine of square root 2 over 2 should equal pi over 4. So, but we found that the sine of pi over 4 is square root 2 over 2, and the sine of 3 pi over 4 is square root 2 over 2. Okay, so there's two places where it's square root 2 over 2. Okay, so that brings us up to domain. Okay, so what in the heck do we do to know which ones we're talking about? Well, for sine, we have to go in between places where we have just one answer. Okay, so for sine, the domain goes from negative pi over 2 to pi over 2. Because if you look at the fourth quadrant, down here, okay, what happens to sine in the fourth quadrant? Sine is negative. What happens to sine in the first quadrant? Every answer in these two quadrants, for sine at least, is different from each other, isn't it? So if every answer is different and they're right next to each other, we might as well use those two quadrants. So the trig gods decided to make the rule that the domain of sine goes from negative pi over 2 to pi over 2. The domain of sine goes from negative pi over 2 to pi over 2. Because we could say, what is the sine of the inverse sine of negative 1/2? Well, where on the unit circle is the sine equal to negative 1/2? Well, there's two places. It's at 11 pi over 6 and 7 pi over 6, correct? But we can only use one answer, okay? And the answer is at 11 pi over 6, but we're supposed to be in between these numbers. So instead of saying 11 pi over 6, we say a negative pi over 6. We say a negative pi over 6 because we have to say in between these two numbers. And 11 pi over 6 is way bigger than pi over 2. Okay? So you use your unit circle, but you only use it to the point of understanding where you're at. So from 0, when you go this direction, you go in the negative amount of what you would go in this direction. Okay? So if pi over 6 is 30 degrees, then negative pi over 6 is a negative 30 degrees. Okay? So what is the inverse sine of negative square root 2 over 2 in terms of radians? Negative pi over 4. Okay?
So you only want to use these two quadrants?
You only want to use these two quadrants with sine, and you have to go in between these numbers. Okay? Yes, Trey Smith.
On the negative half, how did you go from 11 pi over 6 to negative pi over 6?
They're coterminal angles. Remember from the first day of trig in January.
So
Coterminal angles.
you're taking this one here.
Yeah.
And turning it to a negative.
Right, because instead of going up 30 degrees, we're going down 30 degrees because negative pi over 6 is the same place as 11 pi over 6 because they're 2 pi apart. Coterminal angles. That was seriously in January, yeah. We talked about coterminal angles. And actually, the radian coterminal angles, that was about the second section, so it was about the third day that we had this class in January. No, you weren't here.
A bunch of the radiant stuff. I understand calculus to me. I can't remember.
Pre-calculus, I would think
Matrices, and that's all I can.
what I remember in pre-calc is like I'm trying to grow that here now. At least I can go here. Just keep trying to do
Okay. I gotta back up a second. I misspoke just slightly.
Is it range?
It is, this is the range, not the domain. This is what the y values are of the inverse. Okay? So, now, what are the x values that I'm using? So, the domain for the inverse sine. What possible x values can I use here? Okay? Now, if you think about this, okay, we're still in these two quadrants. Okay? We're still in these two quadrants. What's my, at pi, negative pi over 2, down here, what is my y value of this point? Negative 1. So when you're working with inverses, it becomes the x value, right? The y value on your unit circle becomes the x value when you're working with your inverse. So the lowest number that you can find the inverse sine of is negative 1. What's the highest number that you can work with? 1. Positive 1, because you go all the way up to this point, which is 0, 1. Okay? So, the domain here is that. So, I could find the inverse sine of 1. What is the inverse sine of 1? What?
Is it 3 pi over 2?
No. 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 What is the inverse sine of 1? No. It is not pi. Allie, you know it, so you be quiet.
0.
Yeah, there you go. Pi over 2.
I don't know.
Not 0.
I don't know what's happening.
Because hey, listen, at pi over 2, your sine is 1. So when you're doing inverses, the inverse sine of 1 is at pi over 2. So the inverse sine of 1, where does that happen at? It happens at pi over 2. What is the inverse sine of 0? What is the inverse sine of 0? 0. Why do you know that, Allie? You just swagged it, right? Yeah, you just swagged it, but there's a reason why it's 0. Where is the sine 0 at? It's at 0 degrees, which is at 0 radians. Okay? So, Allie, since you're so smart now, Abby, since we're so smart now, well, she already knows what's going on. What is the inverse sine of negative 1? You can get this. I said, Abby. How you doing, Abby?
Bro, I don't know. Try getting the last one. Redemption over. I think it's pi.
Man, this is whack.
It's not 3 pi over 2 because that's not part of our range. It is not 3 pi over 2 because that's not part of our range. You got to think about our range. What is our range? There you go, Aspen. This is not. Once you get it, Trey, once you get it, it's so easy. And Colby's just laughing his guts out because he gets it.
I don't get it.
Right. And I get that you don't get it right now. I get that. Okay? But we just got to keep working through this until we can get it. Okay. At -5 or 2, the sign is -1. That's normal sign. The normal sign at -pi over 2 is -1. Do you get that? On your unit circle, if you go to -5 or 2, you're at 0, -1. The y value is -1. That's sine. So if you flip these two around, that's the inverse. So the inverse of -1 happens at -pi over 2. It is that easy.
Let me think.
It's like that easy.
It says 3pi over 2, but when we talked about this domain and range thing, Liv, we got to be within these areas. Yeah, that half circle. Right. And you've got to do the coterminal angle with your positive ones there. Okay. So, okay. Here we go. To help Liv and some of you others that sort of get it but are not getting it, I'm going to redraw the unit circle. I'm going to renumber it. This is pi over 2. This is pi over 4. This is 0. This is -pi over 4. This is -pi over 2. This point is square root 2 over 2, square root 2 over 2. This point is at 0, 1. This point is at square root 2 over 2, negative square root 2 over 2. This point is at 0, -1. You get all those points, right? What happened down here is instead of calling this 11 pi over 6, we're now calling it -pi over 6. That's the only change. The numbers that it is associated with, square root 3 over 2, -1/2, do not change. It's just these numbers are different. Now, mind equals blown for some of you. I get that. Okay, so now we're going to go to cosine. And cosine's different. Okay, Trey. The inverse sine of negative square root of 3 over 2 equals what?
Pi over 3.
Shh. Nobody shouted out.
That's the inverse. How is it negative?
What do you get, Abby?
Yeah, but it's the same thing.
What are you talking about, Allie?
Never mind. I was looking at cosines. Never mind.
One more,
I
Mr.
read that as
One different one.
I was looking at pi.
It's okay.
3 pi over 2. And then
Okay.
So you can't even, you don't even know.
negative.
So did everybody agree? Here's Rob. One more. One more. No one-
Okay. Abby, you got -pi over 3, right? Okay. Okay. All right. Here you go. Here you go, Trey Smith. Don't anybody shout it out. Here we go. The inverse sine of 1/2.
-pi over 6.
And these guys are all just dying laughing at you, Trey.
I don't get it. How is it positive? You just go to
Wait, no, what is that actually?
No, just go.
No,
Just go. I'm done. I'm done for the day.
Is it not negative? No, okay, so what the thing is? Oh, no, I actually
One more.
right now it's not negative 5%. Oh, because essentially the negative is just meaning something.
Abby, do you get it? No? Where is the y value equal to positive 1/2 on your unit circle? Now, I don't have it written up here, but where is it equal to positive 1/2? The y value.
So how come it's not one more respect. One more.
See how this is negative? So that's why we. Okay. Yeah, for sign, positive, positive, negative, negative. That makes sign a little easy. Wait till we get to cosine, then we're going to confuse the heck out of you there.
One more.
All right. Yeah, I know it. The inverse sign. Do a positive one?
Bro, come on.
Okay. Inverse sine of square root of 3 over 2. This should be easy.
Pi over 3.
Okay. Now, you've got this down. Here we go. Now we're going to do cosine inverses. God, I don't know if we do or don't. Because you guys are just throwing knives at daggers at me right now. Oh, my goodness. Okay, here we go. Inverse cosine. We may not have an assignment. That's not the end of the world. We're still going to get through this. All right, cosine. Okay, thank you. It's a little flat, but okay. Now, cosine. If you look at quadrants 1 and 4, what do you know about the cosines? They're both positives. So we can't use quadrants 1 and 4. So now we got to use quadrants 1 and 2. Ellie Bacanti is so all over this. All right. So, what is the domain and range for inverse cosine? Okay, let's do range first. From where do we start over here to where do we end over here? We start at 0 and we go to pi. We start at 0 and we go to pi. That is the range. It was originally the domain in normal cosine, but now it's the range in the inverse. So what is the domain? -1 to 1, because we always have to start at the smallest number and go to the biggest number in domain and range. But you are right. It starts at 0, it starts at 1, and then it works its way all the way to -1. But when you list it in interval notation, you got to go from negative to positive. But it goes 1 to -1. Okay. So, here we go. What do you think the cosine of the square root of 2 over 2 will be? It's just pi over 4, man. Because the cosine of pi over 4 is square root of 2 over 2, right? So then this inverse cosine of square root of 2 over 2 would be pi over 4. Okay, here you go. Without anybody saying, Yeah, we're doing inverses. That's what all today is about, is inverses.
You have the negative one up there.
It's an inverse. All right. Okay, Eli, here we go. Just Eli, not everybody else. Just Eli. Shh.
Is it negative 5 over 6?
No.
5 over 6.
No.
Is it 5 pi over 6?
Yes.
Wait, what?
Okay, Trey. It is because we're on cosine, not sine. So Trey, it goes from. Okay. Oh my goodness, are they not getting inverse trig functions today? Yep. Yeah. Okay. Yeah, it'll take me just a few minutes, but I already had my prep today, so it'll do. Yep. Yep. Bye. Okay. So sine, Trey, undivided attention here, man. Sine went from negative pi over 2 to pi over 2. Cosine doesn't use this down here because it's the same as up here. So we have to go here to here. So when we go to here, we got to go, we forget any negatives, and it's always going to be a positive answer anywhere in between 0 and pi for cosine. Okay. These answers over here, the x values are negative. Yes. But that'll be the x values that we're talking about. We are going to be looking for the y values, which are the x values. All right. One more. I think we got to do like 5 more. But I think Eli's feeling good here. Okay. The inverse cosine of negative 1/2.
That's 2 pi over 3.
What?
Wait, what?
You got it right.
Oh, yeah. I was questioning my life decision, and that was crazy. By the way, I got that one. I was not out.
Okay. Trey,
Yeah.
here you go. Shh. Shh. Guys, relax. Yes, I'm recording all this. Kate's gonna love this.
We're not mentioning Ethan Brown.
We already talked about Ethan. I talked about Ethan back by the phone.
0. What is it?
No, man. Come on, man.
Pi over 2.
At pi over 2, the cosine is 0.
No, I go 1 and I go 0.
Abby Allen, here you go. This one's all for you. The inverse cosine of negative 1. Yes! We are getting it. All right. Let's go to tangent. Go.
Bro, I'm not trying to get my homework.
We're not gonna have homework. We're having way too much fun to have homework. All right. If this could be teaching every day, I would teach till I'm 80 years old. I love I love it when you guys are just struggling, and then you figure it out, and it's like, yes! It's the aha moment. I just love that. Okay, tangent. Now, let's think. Hey, Trey, focus, man. Focus. Let's think back to chapter 2. Chapter 2, we had them asymptotes going on, right? And the tangent curve looked like this, right? No, you don't have to draw this again. Okay, so we had asymptotes. So then what happened here? We could not touch that, right? Because it is undefined. Why is it undefined? Because we are dividing by 0. Okay, woo. All right, so where did those occur at? Where do you divide by 0 when you're working with tangents? At pi over 2 and at 3 pi over 2, which is coterminal with? And to make life sane, we do the same for tangent as we do for sine. So it goes from negative pi over 2 to pi over 2. So the domain and the range, we'll talk about range first because I think that's easier. The range is your original domain. What's your original domain? Negative pi over 2 to pi over 2. Okay, so what is your domain? Okay. What? Careful here. This one is tricky. What will your answers be? Okay, calculators. Okay? Now, let's take the normal tangent of pi over 3. What does that equal? That equals square root of 3, basically, right? Square root of 3, which is 1.7 something. Okay. Let's take the tangent, and this is not on your unit circle, but let's say we take the tangent of 7 pi over 16. You can do it on your calculator if you're in radian mode. 7 times pi divided by 16. 5 point what? 027. Okay. Let's take the tangent of 21 pi over 43. 27.36. What's 21 over 43 really close to? 1/2. Let's take the tangent of 99 pi over 200.
63.66.
Okay. So what are you noticing as the closer we get to pi over 2? Because we said pi over 2 is undefined. That's undefined. So really, our range is not this. Our range is this. We need parentheses because it cannot equal that. Okay. What is happening to these numbers as we get closer and closer to pi over 2? They're getting bigger. How much bigger? Well, where is this line going towards? Infinity. So the domain goes to infinity here. Where does this part of the domain go? Negative infinity. Ooh. All right. So now I'm not going to worry so much about the infinity, negative infinity. I'm just going to focus on the big stuff here. So let's get back to stuff you can handle. What is the inverse tangent of 1? Okay, don't shut it out, Ellie. Think about it. Think about it. What is the inverse tangent at 1? Where would you go to get a tangent of 1?
Oh yeah, look at that.
I got some people saying pi over 4. I got some nodding, head nodding. Because the tangent of pi over 4 is 1. So the inverse tangent of 1 is pi over 4. All right. All right. Okay. Difficult one here. Difficult one. Well, some people it's like, yep, I got it. But, and I think you're wrong. Inverse tangent of negative square root of 3.
Oh yeah.
According to Miles Devaney, it's negative pi over 3.
It is, yeah.
Eli's confirming that. Colby's going, yeah, we're going with that.
Steve's not saying yeah, are you? Oh, he's saying yeah. Wait,
Steve's saying yeah. Negative pi over 3.
Yeah, he is.
Can you do all these on your calculator? Yeah, but how are you going to know that the decimal that it comes up with is negative pi over 3? You just know? Okay. Then, yeah. Guess and check. Yeah. Okay. What time do we get out of here? 31. Okay. So, did you kind of sort of get to this? Because Monday, we're going to come back and we're going to hit this with secants and cosecants and cotangents too a little bit. And then we're going to have a good old assignment.
So it's kind of just where is it on the unit circle that equals that?
Yeah, basically.
It's mostly, but you have to use the negative instead of using the actual number.
So we will see you. Oh. Because some of you are going to be gone tomorrow. I got to hand out the project.
You like seeing us.
Semester project. Tomorrow, this is what we are working on in class. It is a packet. 16 problems. That's all the project is, 16 problems, 16 written. So, you get packed up? Whatever. Good luck at the course today. I'll be out there later.
Oh god, that's a lot of Trig identities. That shouldn't be too terrible.
Hello, Ethan.
Your turn is not coming. That one girl, that one girl, that one that I.
That wasn't
Oh my God, I hate her.
Yeah, and you would be gone.
Yeah, I hope I never have to go to the third this year. I hate her.